Hello everyone. So today in this runtime generated landscape we are going to fix this problem of seams. Now as you can see, we have in this landscape we have 4 tiles, and in the boundaries of these tiles you can see this ugly seam. See, so you get a difference in the normal, so that's why you get this change in shading and also change in these textures. So if I enable buffer visualization and world normals, you can clearly see this line. So this difference comes from the normals of the mesh, and because the normals are not matching at the boundary, we can see the material texture difference as well, because the material is also using the normal of the surface to calculate the texture, because we are using an auto material. So even if we don't have that, even if we have a same texture regardless of the slope, we will see this as a difference in shading or shadows, and this is the problem we are going to address today. So once we fix this problem, we would not have this seam, so everything will be perfectly seamless across different tiles of the landscape. Okay, and before we get started, as always, I'd like to remind you that you can download the project files of this project and all other projects that I have done in my channel in Patreon page. Once you become a member, you can download everything without a limit. So feel free to check it out. There are over thousands of projects in my channel for you to download. And back to the tutorial. So let me open my PP World Blueprint, which generate the landscape. Now the problem happens here. So this is the generate terrain. This is the function that generate one of the tiles of the landscape. So using this function, calculate tangent for mesh, I generate the normals, and these are the normals I use to create the mesh. So the problem is, into this function we only give the vertices and triangles and UVs of this tile only. So because of that, for example, let me make this a 1x1 landscape. So that means we will have only one of the tiles. So if I go to the top view, so here let me make this a little bit simpler, like this. Right now, so when we calculate a normal of a vertex, so vertices are these points. This is one of the points, this one, this one, this one. So these points, these are the vertices. So when we calculate the vertices, I guess, let me get some more space. So let's say if I consider this in a horizontal slice, let's say one vertex here, another vertex here, another vertex here, another vertex here, like this. So if we consider only one axis, maybe this is how it looks. So when we calculate the normal of this one, like this, it might be using this vertex position, this vertex position, and this vertex position. So for any vertex in the middle, it works perfectly. But for the vertices in the edges, now here we don't have any detail about what might be the vertex position here, because that may be in another tile, that is in another tile. So unless this is an edge of the landscape, this vertex is another tile. But we don't have any detail about its location. So therefore, I guess it might be doing some kind of assumption, or like using a default value, like it is in the same level or something. I'm not sure. Actually, I haven't really looked into the exact implementation of this function. So anyway, if we have the correct value to this vertex, then this vertex will also get the correct normal. So it may be something like this, because the actual landscape may have a slope like this when in the next vertex. So in order to get this, what can we do? So even though we are only going to render this part of the landscape, this part as the mesh, what if we fill or calculate vertex points for these vertices as well, and give them into the function? So we will have something like this. So I'm not going to draw this. I hope you get the idea. So we will calculate the vertex points for a terrain tile in this size, and using that we will calculate the normals for a tile like this. So then we will have correct normal values for this tile. The edges of this one, these edges will still have wrong values, but we only need to get the correct values for the inside vertices. So we will get the correct values. That's what I'm hoping for. Okay, so how do we do this in our blueprint? So for that, so as I said, we need to calculate vertices for a bigger chunk or bigger tile. So I guess we have to start from -1 here, because we should start, as I mentioned here, if this is 0, 0, we should start from -1, -1. So start from -1, and previously this is the last one, but now we have to go the last one plus 1, last one plus 1 in both directions. So that means we don't need this -1 part. So I'll directly connect like this. Now we will have the vertices and the UVs for that bigger tile. Okay, so now when we calculate triangles for that bigger tile, how should we go about that? Well, here we are using this vertex count -2, but in this case our vertex count would be vertex count plus the original vertex count plus 2. So that means original vertex count plus 2 minus 2, that means directly this value for both x and y. So here now, instead of the vertex count, we will have to use vertex count plus 2. I don't think for the calculation I have to change anything else. Right. So now here, if I directly draw this, what we would be doing is drawing a bigger triangle. This will still work even if I have multiple tiles, but I think at the edges we will get an overlap. So it's not visible from here. You can still see the seam, but there should be an overlap. Duplicated, yeah, maybe this. Here we see something like this. Fighting, going on, so that may be because of the overlap. Okay, so anyway, the seam is still here. It should be still here because we didn't fix anything yet. See? Okay, now what we need to do is we need to calculate the tile of the original size. So now this vertex, triangles and UVs, we have those variables hold the values for this bigger tile. So let me create a function. Me put it like this to get the order, and then select these and collapse to function. I'll name this get subset. Okay, now I'll rename this out vertices, out triangles, out normals. So this will make things easy, clear. Out UVs and out tangent. So out is the subset or the smaller tile. This I'll name it in vertices, in triangles, in UVs, and we got an error. Right, this okay. Oh, this shouldn't be a global variable. It should be a local variable. Out this. Oh, I can't have the same name. Outwards. Okay. Out this. Out UVs. We don't have a shorter name here. Oh wait, let me just remove part. That will make things easier and clear. Right. No. Triangles. Tangents. All right. Now we got all the variables we need. Now we need to calculate. So the return of this, I'll promote this to another local variable. I'll call it big normals. The reason I call it big is because this is the normals of the bigger tile, and big tangents. Okay, now After this, now we need to identify from these bigger arrays the values that create the smaller tile. That means we may have to run this again, double loop again. So then this one I'll create this one. So this is x index and this is y index. So if this x index, in order to qualify as a vertex or a normal or a tangent of the smaller triangle, this is the condition this x must satisfy. This should be larger than -1. That means, so basically we are filtering out the vertices values at the edges, filtering out these edge values. That's what we are doing here. Should be larger than -1 and should be less than the vertex count, x vertex count, because originally it should go until vertex count -1. So only for the bigger one it goes to the vertex count itself. Similarly, for y also the same conditions. Get the y vertex count. Right. Okay, and all these conditions should be true. So do an AND with all these 4 conditions. Okay, so if this is true, that means this is this index is value belongs to the subset that we need. So to access, okay, we need to first get vertices. So get in vertices. From this get, oh, we need a variable here. I'll add another variable. I'll call it index. And add to out vertices. Okay, now that's vertices. Then we need to calculate get UV. So same as this, get in UVs. From that get a reference using the index and add to out UVs. Right, now same thing with normals. Now normals we have in this big normals and tangent. So big normals get index. And add to out normals. Same deal for out tans. Big tangent, get a reference using the index and add to out tangents. Oops. What else? Okay, we got vertices, UVs, normals, tangents. The only thing remaining is triangles, but triangles is not this easy. So okay, here, so after this we need to increment this index, otherwise we will be getting the same value. And even if this condition is not true, we have to keep incrementing this index. Okay, so what about the triangles? So actually for that we may have to use this original code, I mean, and recalculate, because I'm not sure how to filter out from the big triangles array, because this triangles involves 3 points, so it's a bit complicated to filter. Therefore I'll just get the easy route and do the calculation again in the original way. That means here, let me copy this, get some space, paste. Now we should start after these 2 loops are completed. So here, as I said, we should do this in the original way. We need the smaller tire, so we don't need this +2 that we added before. Right, now instead of triangles I'll replace this with out triangles. Okay, now the triangle calculation is done. Then we can finally return this. Completed and return. Okay, we did a lot actually without testing, so hope everything is still working. Yeah, see, now we don't really see any seams in the normal. Now let me make this bigger. Alright, it's smooth, no seams at all. Cool. So our method is working. Let me go back to the lit view. So no breaking of textures like before. It seems correct. Our material is not good, it doesn't look nice, but it's correct. No seams. Awesome. Okay, so I mean, even if I increase the number of sections, so change the parameters, this should still work. Yeah, so still works correctly. So that's it for today. And since our code is getting complicated, maybe we will have to switch to C++ or replace some of the functions at least into C++ for performance issues, to improve performance, because once we start implementing the infinite terrain as we generate in the runtime as the player moves, we might hit some performance hiccups. So let's see about that in future. And thanks again for watching. So feel free to let me know what you guys think, and comments, criticisms, whatever you want to say in the comments. And see you in another episode. I'll put the updated project files in my Patreon page and the link in the description below. And see you in the next episode. Goodbye.